Good morning, judges, ladies and gentlemen. My name is Pimchanok Rimdusit. Today, I'm very pleased to present our research project in the title, Mechanical Force Modulates Inflammation and Osteogenic Activities of Periodontal Ligament Cells under Gingival Inflammation in Vitro Model. Therefore, the use of mechanical force such as mechanical toothbrush and orthodontic force in periodontitis is controversial. Periodontal ligament receive the signal from the surrounding gingival tissue. Priming cells with mechanical force have been reported to affect the adjacent periodontium. Does the mechanical shear force affect inflammation and osteogenic activities of human periodontal ligament cells under gingival inflammation? Mainly, our research objected to investigate the effect of gingival fibroblasts receiving mechanical shear force on PDL cells on an anti-inflammatory and osteogenic differentiation. First, shear force by automated shear apparatus were applied on the gingival fibroblast at 500 RPM for 6 hours, which is equal to 7 dye per square centimeters. Then, the medium was collected as the conditioned medium for PDL treatment afterwards. Next, the culture PDL from the same donors were pretreated 24 hours with cytokine cocktails containing interleukin-1 beta, tumor necrosis factor alpha, and interferon gamma to mimic the non-bacterial inflammation. For the bacterial inflammation, we used Porphyromonas gingivalis lipopolysaccharide. After 24 hours, we treated them with the conditioned medium from the shear gingival fibroblast for another 24 hours. Lastly, we used the osteogenic medium to culture the PDL for 14 days. Our results show that the gene expression of collagen 1A1 of the gingival fibroblast significantly increased, while IL-1 beta and IL-6 is down-regulated, which could imply that there is no significant inflammatory effects of the shear force on gingival fibroblasts. The gene expression of PDL induced by gingival fibroblast conditioned medium show no significant differences in IL-1 beta, IL-6, and TLR4. So, it was found that priming mechanical force on gingival fibroblasts did not affect PDL inflammation. After treated in osteogenic condition for 14 days, there are no significant differences in ALP. But in round 2 show upregulation trend in the LPS pretreated group, but not in the CC pretreated group, which could be confirmed that mechanical shear force on gingival fibroblasts could increase PDL osteogenic activities in bacterial condition. However, in normal condition, shear force from gingival fibroblasts did not affect PDL osteogenic potential, but in inflammatory group show an increase in osteogenic formation confirmed by a resident red nodule formation. For the discussion, periodontitis patients usually less down on orthodontic or using extra mechanical electric toothbrush because mechanical stress was one of the factors believed to enhance more inflammation in periodontal tissue. Reversely, our study showed that shear stress has no effect on gingival inflammation in gene levels. Thus, inflammation-related protein should be further investigated to confirm whether mechanical shear stress has an effect on gingival fibroblasts. When treating PDL with GF conditioned medium, differences in osteogenic activity between non-bacterial and bacterial group were observed. Round 2 were increased in bacterial inflammation group but not in non-bacterial inflammation group. These differences could be explained through differences in their signaling pathway. PGLPS, TNF-alpha, and IL-1 beta were stimulated through an F-kappa B pathway, while interferon gamma triggered through JAK-STAT pathway. Presumably, the JAK-STAT pathway is one of the factors that affect different response of the inflamed cells to the influence of mediators released by shear force-induced gingival fibroblasts. However, a recent rate show increased mineralization in both inflammatory groups. Thus, it is recommended that the pathway should be further clarified. In conclusion, our study reported that in healthy PDL, no osteogenic or inflammation were activated when the gingival fibroblasts received shear force, while in the inflamed PDL, cytokine from shear force-induced gingival fibroblasts can promote PDL osteogenic activity, but not the inflammation. Thank you for your attention.